Imagine you've just launched a brand new restaurant booking app. On day one, with just a few hundred users, everything feels magical. You tap a button, and a reservation pops up instantly. Then day 10 arrives. A huge food influencer drops a video reviewing your app, and suddenly, 100,000 hungry people rush in to secure a table all at once. Instead of that snappy response, your users are suddenly staring at an endless loading spinner. People are just trying to search for a local diner, but the app has practically frozen. It is easy to blame a coding error, but these slowdowns happen because of a strict mathematical limit on how computers store information as they grow. By default, when someone makes a reservation, the system simply drops that new piece of data at the very bottom of a list, exactly as it arrives. By day 10, you don't have a neatly filed cabinet, you have a massive, unsorted pile of digital receipts. This animation illustrates the problem. When a user searches for their booking, the computer has to start at the very top and check every single row, one by one, until it finds a match. Engineers call this a full table scan. You might think throwing more powerful servers at the problem would fix it. But when you go from 1,000 records to 1,000,000, even the fastest computers cannot outrun the sheer volume of disorganized clutter. To survive a viral traffic spike, you cannot just try to read a messy pile of data faster. You have to rethink how you organize the information in the first place. This brings us to a tool called an index. Think of it like the index at the back of a textbook, a separate, highly organized list that acts as a shortcut to the main material. A primary index takes a unique identifier, like a booking ID, and keeps them perfectly sorted, separate from the main pile. Next to that ID is a coordinate telling the computer exactly where that reservation lives, so it can jump straight there. Instead of scanning millions of rows to find one reservation, the computer skips the line entirely. A search that used to take 3 minutes now takes a fraction of a millisecond. The computer performs a targeted, precise strike instead of searching through a massive digital haystack. There is just one catch. Real people almost never search for things using a 16-digit alphanumeric code. They want to search by the name of the restaurant, or maybe their phone number. To solve this, we create a secondary index. It sorts human-friendly information, like restaurant names, alphabetically, grouping identical names together. If someone searches for Joe's Diner, the system finds it instantly and follows the arrows to gather every matching reservation all at once. When you use an app to filter for a pizza place available at 7 p.m. on a Friday, you are actually asking the system to cross-reference multiple secondary indexes, one for the food type, one for the time, and one for the date. These organized lists are the hidden engine that turns a dumb digital storage locker into a fast, intuitive search engine. If indexes make searches this incredibly fast, it seems logical to just create an index for every single piece of information in our app. But database storage has a strict golden rule. Every index you add to speed up your searches actively slows down your ability to save new information. This animation shows the right penalty in action. When a user books a table, the system saves the record in the main pile, but then it has to pause. It must stop and meticulously update the index for the restaurant name, then the index for the time, then the index for the date. All of that extra administrative work takes heavy processing power. Plus, maintaining a dozen different sorted lists means you are duplicating data over and over, rapidly eating up your storage space. If you add too many indexes, your lightning-fast search system will freeze up the moment thousands of people actually try to hit the Book Now button at the exact same time. To prevent these traffic jams, engineers have to step away from the code and look at how human beings actually use their app. They study which buttons get clicked and which search bars get used the most. The most successful platforms do not index everything. They carefully build indexes only for the specific details people search for constantly, and leave the rest alone so that new reservations can be saved without delay. The result is a beautifully balanced system. It can instantly find a needle in a haystack for a searching user while smoothly handling a massive wave of incoming reservations. Scaling to millions of users requires mastering the art of the compromise, finding the exact balance that fits what your specific users need.